Welcome to Everyday Mathematics. Today we are on the 2021 Universal Florida Integration B qualifying round. This is part 3 where we'll be looking at problem number 9, problem number 10, problem number 11, problem number 12, and problem number 13. So without much ado, we'll be jumping on to the solution phase of this video. But before we go there, I'd like to encourage those of us who are here for the first or second time and haven't subscribed, please do consider subscribing to our channel. Here at Everyday Mathematics, what we do is we go about and around and look for interesting mathematics problems, and we try to share with you. So if you can spare a moment and just press on that subscribe button, we'll so much appreciate your collaboration and support on this. So let's move forward to the solution phase. What is interesting here is we're going to look at problem number 9, which is we have polynomials all around, and I think what they're trying to examine here is the ability to simplify this polynomial in a short time. So how I'm inclined to operate and work on this problem is I'd like to rearrange it so that I can substitute for the x minus 1. So I'll rearrange my problem like this. So x minus plus 1 here can be expressed as x minus 1 plus 2 squared. X can be written as x minus 1 plus 1 over x minus 1 cubed. And so we can say now let u be equal to x minus 1 such that du dx is equals to 1, meaning that du can be used to substitute for dx. And so we can rewrite our problem as in place of u plus x minus 1, we have u. So we have u plus 2 squared over u plus 1 over u cubed. And in place of dx, we have du. So this becomes, using binomial expansion, u plus 2 squared is the same as u squared plus 4u plus 4. And then u plus 1 to the cube is the same as u cubed plus 3u squared plus 3u plus 1 times 1 over u cubed. And so we can begin multiplying this by each individual items there. So we have u to the 5 plus 4u to the 4 plus 4u cubed plus 3u to the 4 plus 12u to the 3 plus 12u squared plus 3u to the 3 plus 12u squared plus 12u, and then we have u squared plus 4u plus 4, close bracket, times 1 over u to the 3. And so we can begin collecting like terms. We have only one u to the 5, and then we have this and that. Okay, and then we have this and that. Okay, and then and that. Okay, and then we have that and that and that, and then we have that and that. So we have u to the 5, there's only one of it here, U to the 4, we have this and this, so which is 7 U to the 4. And then to the 3, we have this, this, and this. So that is 19 U to the 3, 4 plus 12 plus 3. And then we have this and this and this, which is 24 plus 1, which is 25 U squared. And then we have 12 plus 4, which is 16, plus 16 U. And then we do have 4. Okay, so we definitely have quite a lineup. We have U to the power 5 plus 7 to the times U to the 4 plus 19 U to the 3 plus 25 U to the 2 and then plus 16 U plus 4. All this multiplied by 1 over U to the 3. Okay. So I think let's just begin by rewriting what we were able to come down to. So we have U to the 5 plus 7 U to the 4 plus 19 U to the 3 plus 25 U to the 2 plus 16 U plus 4 all over U to the 3. This equals to U squared plus 7U plus 19 plus 25 over U plus 16 over U squared plus 4 over U. There. So integrating item by item, we have U over 3, to the power 3 over 3 plus 7U squared over 2 plus 19U plus 25 natural logarithm of U. And then here we have minus 16 over U. And then we have minus 4 over 2U squared. So let's delete that. Plus the integration constant C. But we said U equals to x minus 1. And therefore, our initial problem of x plus 1 squared, x over x minus 1 cubed, is equal to x minus 1 cubed over 3 plus 7 over 2 times x minus 1 squared plus 19 times x minus 1. We realize it could also just be 19x, where we make negative 19 part of the constant. And then we have 25 natural logarithm of, or some people could use ln. Whatever you choose is fine. X minus 1 minus, rather, minus 16 over x minus 1 minus 2 over this 1, this 2. So 2 over x minus 1 squared plus the integration constant. So I think what we may end up doing is we might bunch this constant here with this constant here, and so that we're left with x minus 1 cube over 3 plus 7 over 2 times x minus 1 squared plus 19x plus 25 natural logarithm of x minus 1 minus 16x minus 1 minus 2 x minus 1 squared plus the integration constant. So maybe we can rewrite our problem just succinctly. We said, okay, x plus 1 squared x over x minus 1 cube integrated is the same as x minus 1 over 3 over cube 7 over 2 x minus 1 squared plus 19x, okay, plus 25 natural logarithm of x minus 1. Some people may put absolute sign around that, but we'll just leave it there like that. And then we have 2x minus 1 squared plus the integration constant. And that, ladies and gentlemen, is our solution. Number 10, which is the indefinite integral of e to the 3x times sine of x plus 2. There are many ways to solve this problem. There are going to be two steps that I will undertake. First, what I'm going to do is substitute for x plus 2, and then 2, use Euler's formula for the sine function, and then 3, take the imaginary part of Euler's formula. So let's begin with number 1. So we're going to say let u be equal to x plus 2, right? So our integral becomes, first of all, we have to say du dx is equals to 1, and that means du can be used to substitute for dx, right? So 3, e to the power 3, x becomes u minus 2, and then sine u. Okay, so we can pull the constant out, e to the power negative 6, e to the power 3u sine u. Okay, since we know that e to the power ix is equals to cosine of x plus I sine x, then it means sine x is equals to the imaginary part of ix. So we can now say that our integral is simply equal to I imaginary of okay. So this becomes E6, the imaginary of integral of e to the power 3u times e to the power iu. Which is m imaginary of e 3 plus I u. Okay. So this becomes e to the 6 imaginary of 1 over 3i e plus the integration constant. So we can try to remove the imaginary component from the denominator, and how we do that is we multiply the numerator by 3 minus I and then 3 plus I. So this is a complex conjugate or whatever is the denominator. Okay, so since we have times the imaginary of 3 minus I over this here is the same as 9 plus 1, which is 10. So we have e over 6 times 10, over 10 times the imaginary of 3 minus I, e 3 plus I, u plus c. Okay, we could always pull this 3 to the power. So we have that e that out times the imaginary of 3 minus I e so this part here is the same as cosine of u minus I sine of u. And so if our problem is we can multiply that out and say, okay, this is the same as e 3 u minus 2 over 10, the imaginary component of 3 cosine of u plus 3i sine of u minus I cosine of u plus 3 sine of u plus c. So the imaginary part is this and this. So in other words, we have e 3 10, and then we have in bracket 3 sine of u minus cosine of u plus c. But we said let u be equal to x plus 2, and so also, yeah, that's what we said, meaning that if our solution is as shown here, then the integral that we initially have, which is a 3x sine x plus 2 integrated, is e to the 3x over 10 times 3 sine x plus 2 minus cosine of x plus 2 plus the integration constant. And that is our solution. So we chose to use a windy solution, but all the same, I think it brought us to what we wanted. 11 happens to be the definite integral from x equals to 0 to x to infinity of x to the power 201 times e to the power negative x. So we're going to use integration by parts. And what does integration by parts tell us? Integration by parts tells us that if you have an integral of a function v times the derivative of function u, we have, and you integrate that, we have uv minus function u times the derivative of function v. So first we're going to express this expression here in this formalism. So this becomes 0 to infinity of x to the power 201 times the derivative of negative, okay, so that our uv becomes negative x to 1 e to the x 0 to infinity plus the integral from 0 to infinity of 201 x 10. This is the derivative of function v, which is this e that. So as we can see here, limit x tending to infinity of negative x 201 minus limit x tending to 0 of negative x 201 e to the power x. Let's rule that out. Okay, so as x tends to infinity, and you could actually express this as x to the power over, and then you realize that both the numerator and denominator tend to infinity, and then you could do L'Hopital's. And the derivative of numerator of the derivative of denominator, and you continue doing that until you get to a point where you have and you realize that now this tends to 0. So in other words, this guy tends to 0. And this also, because this tends to 1 and this tends to 0, so this also tends to 0. So in other words, we've come to let's say, let's delete that and write it properly. So our problem has become now 201 times the integral from x equals to 0 to infinity of x to the power 200 times e to the power negative x. And this will continue until we come to a point where we have that. Because we'll keep iterating, and the intervening components will just go to 0 if we continue doing integration by parts. And so this becomes 201 factorial negative e to the x. And so if we have limit x tend to infinity of negative e to the x minus limit x tending to 0 of this goes to 0, as we know, and this goes to negative 1. And so minus minus 1 becomes 1, so our answer is 201 factorial. And so our integral 0 to infinity of x to the 201 e to the x goes to 201 factorial. And that is the answer. So problem number 12 just happens to be a definite integral from x equals negative pi to x equals to pi of sine 5x over 2 over sine x over 2. So this is a problem that exploits what we call the Dirichlet kernel. And for those of you who have time, you could just easily go and prove that this equals to this. And so what do we do now? Our n in this instance, so we can express our integral as from pi to pi of sine of so 5 over 2 is the same as 4 plus 1 over 2, which is 2 plus a half x over sine of x over 2, which is equal to, we can use this intervening expression, which is equals to the integral of 1 from negative pi to pi plus 2 summing from k equals to 1 to 2 of cosine of kx. So this is same as the integral of 1 plus the summation, or twice the summation from k equals to 1 to 2 okay. So this is x negative pi to pi plus 2 summation from k equals to 1 to 2, and we have 1 over k sine of kx negative pi pi. And so we see that sine of any integer times pi is 0. So taking the limits both at this and that means that this entire thing goes to 0. So we come to x, which is equals to pi minus pi, which is 2 pi. Therefore, integral from negative pi to pi of sine of 5x over 2 sine x over 2, having used Dirichlet's kernel, becomes 2 pi. And that's the answer. Number 13, which just happens to be the integral from e to the x, the indefinite integral of e to the x times sine of e to the x. I think the important part is substituting for e to the x, and we can just say let u be equal to e to the x, such that du dx is equals to e to the x. So we can substitute with du for e to the x dx. And so these two parts, the product of that can be substituted off. So our problem becomes the integral of sine u, which is negative cosine of u plus c. But since u is equal to e to the x, becomes, and that is our answer, ladies and gentlemen. So that brings us to the end of our session today. Without much ado, we'll close this session. If you haven't subscribed to our channel, we do encourage you to consider subscribing to our channel. Your support and collaboration will go a long way in helping us popularize this channel. So until next time, have a blessed day ahead.